Good morning. My name is Ofelia Araújo, and I am very pleased. It is a privilege to chair the invited lecture of Professor Natasha Markowska, addressing the challenge of limiting the global warming nearly a decade after the Paris Agreement. Her lecture is entitled After 1.5 degrees C, Managing the Overshoot Without Losing the Target. She will approach the scientific evidence that we will exceed the 1.5 degrees C threshold, potentially for an extended period. Yet, Professor Natasha acknowledged this reality. She calls for reframing our approach to manage overshoot while maintaining the target. Presentation will explore critical intersections between climate mitigation, sustainable development, and public health benefits going beyond carbon reduction alone. Importantly, it will also challenge narratives that weaponize high-cost or slowly deploying technologies to justify extending fossil fuel dependence. To address this complex challenge, we are honored to have Professor Natasha Markowska from the Research Center for Energy and Sustainable Development, Macedonian Academy of Science and Arts. Natasha Markowska holds a DSc degree from the Faculty of Electrical Engineering, Skopje, with thesis on solar technologies. At present, she is a senior researcher at the Research Center of MANU and professor of the subject Energy and Climate Change at 2 master programs and a doctoral program of Faculty of Electrical Engineering and Information Technologies. Also, she serves as a national focal point on the Intergovernmental Panel of Climate Change, IPCC, and a member of the International Scientific Committee of the Conference on Sdewes. Okay. She has been participating in 124 international and national projects related to climate change, mitigation, sustainable development, renewable energy sources, as at UNDP, World Bank, European Commission, GIS, Macedonian, and other governments. In this field, Dr. Markowska's co-authored 210 published contributions, 16 in high-impact journals, with H index of 25. She serves as a subject editor of Energy, section chief editor in Environmental Energy Economics Policy, Elsevier's publication, Energy Report, and associate editor, Elsevier's Smart Energy. She served as an editor of the second national communication under UNFCCC and as a guest editor of 26 special issues of international journals dedicated to Sdewes conference. Professor, the floor is yours.
Hello. Yes, it's okay? Yes. Okay, 10 years ago, at the same Sdewes stage in Dubrovnik, I asked a question about mitigation, will we make it? And today, we're gonna have a new, slightly revised question in the new circumstances when overshooting is almost likely. And also we have some success, but not enough to align to a final goal of 1.5 degrees. Let me start by saying some words about how the goal under Paris Agreement was devised. In fact, it was an ethical decision, not a technological one. It was not driven at that time by the available technology on what was possible to be done, but rather how much of the damages is acceptable for humanity, and also that the costs for adaptation and managing the damages should be still lower than investments needed for appropriate mitigation action. So 1.5 degree was never meant to be a comfortable or easy. It was always used as an ethical compass to manage the risk associated to climate change. And it was more meant to be a direction, not a comfort. Let me just here remind you about the analogy with zero target dates for road safety. Well, we never managed to achieve this goal, but still we are not abandoning it, right? So it was an ambition, adequate ambition, to enable the humanity to manage adaptation and damages of climate change, but still it is not enough to deliver outcomes. Here we have to have financial investments, ready institutions, and even human capacities to deliver to reach the outcome. And yesterday, and even more and more, it has been even in the last report of the stock taking of Paris Agreement in 2024, it is clear that the reality diverges from the ambition. And when we have this kind of situation, really what is important is how we interpret that divergence. So we are almost sure that the overshoot is coming. And understanding overshoot, understanding what it is and what it is not, it's really the most important question which will guide our action on the road of road on transition towards zero carbon societies. Well, overshoot is happening, and indeed it was anticipated by the science. If you see if you analyze the 1.5 degree pathways within the most relevant product of IPCC, that is 1.5 degree special report, we will see that many of the 1.5 degree compatible pathways actually are following overshooting trajectory. So it is not new. And let me just here provide an analogy with control systems. And it's not about, everything is about what will be a steady state outcome, and not the way how we come to that steady state. And indeed, for the Paris Agreement, it was the end year target, 2100, that the goal is posed, and not the peak year. So we knew that in a way that it's gonna happen. It was anticipated by the science, and even at that time, some credible solutions were offered to follow this trajectory. Well, again, current trajectories have shown some progress, but it is not enough, and we clearly see that we are not really close towards achieving the goal in the year 2100. But this overshoot sometimes, or maybe better to say very often, is used as an excuse for not doing action, or to proclaim that Paris Agreement is dead, or to delay the action. Often is misread as a failure. But let me show that later on it is not a failure, but rather it's a direction for the future. And we are always very often witnessing this kind of headlines in the journals, but also in the scientific papers, which sometimes may introduce some bias and delay the action. So overshoot is not really what is the danger. The real danger is the abandoning the ambition. Still, what is shown here on this slide called 0.5 degree still matters very much, because as we see, we have exponentially higher impacts on the human and the nature just between these two goals. And also adaptation costs will explode. So it's still worth to stay with this target. Well, if we can recognize that overshoot is reality, the question now becomes, how do we manage it? So, to manage it, not to surrender, and to transform the emotion into strategy, and the debates into tools and actions. I mentioned tools. So, managing overshoot requires tools, not surrender. Tools, analytical tools, political tools, policy tools, also institutional capacities. And going without saying that here the integrated assessment models would be the one of the models which have much to say when we use some tools to address the climate action. So basically, the models are the ones who translate the targets into various actions and various outcomes. So let me just briefly explain how these integrated assessment models work. So we have a number of inputs like population, GDP and economic growth, policies, and other societal assumptions. And they come together in a block of interacting components like economy, energy, land, and climate. And all of this, they produces some information about emissions, energy, economy, and land use. So, but the models, it's not just calculating the emissions. It is also translating the assumptions into emissions, into energy pathways from the land use and for the economy. So integrated models are powerful tools. We need them to address analytically the climate action, but they are not perfect. They are incomplete. So powerful integrative tools because many of the areas of the societies are integrated, but because of that, they needed to do some simplifications, particularly for the energy sector. And these simplifications really matters about the outcomes, really matters how the outcomes will be interpreted, and particularly in the world of overshooting. Because these limitations of the model could produce some outputs which will be not favorable to manage the overshoot. So, first of all, integrated assessment models are not designed for highly renewable energy systems. If we go and analyze the 1.5 degree pathways in the 1.5 degree special report of IPCC, we will see that none of them would produce this 100% renewable as a cost-effective option. We have strong aggregation over technologies, space, and time, and also simplified system flexibility, like storage, like demand response, like sector coupling. And all this has implications on that, how we judge the feasibility. And often, as a result of this limitation, we have favored dispatchable options, and high renewable energy options are constrained. So, in fact, what is important here, the feasibility is not like a technical category, but rather it is shaped by the model limitations. Underestimated potential of renewables and flexibility result in overestimated reliance on future carbon removal. And also, as I mentioned many times, a delayed mitigation appears cheaper. So we have a number of policy narratives like immediate action is too costly, or we can wait, we still have time. So feasibility becomes a modeling outcome, but not a physical one. We engineers often use some tests for our models. And here, if we want to stress test the integrated assessment models with 100% renewable energy systems, we need to test whether variability and flexibility can be managed. This test, we want at the end systems with high share of wind and solar to be at the end balanced and reliable. But we cannot succeed this with integrated assessment models. But the other energy system analysis models reveals that this feasibility, in fact, is in our hands, and they shift the question of feasibility not if, but to how. How we can, but if we implement detailed energy system models. So there, in these detailed energy system models, variability can be managed with storage and flexibility. Also, sector coupling enables system-wide balancing. Reliability is achievable without fossil fuel base load. In these systems, modeled with detailed energy system analysis models, in fact, the needed functions of the systems like reliability, adequacy, and the others, which were traditionally provided by the fossil baseload, now can be provided but with flexible resources. And not only by one technology, but it's between many interacting technologies spent across a all energy systems. That's the logic of implementation of 100% renewable energy systems. And here is the example of one such a energy system modeling tool, H2S. It has detailed representation of the technologies, very hourly time resolution, and also all these necessary flexible resources adequately represented, so the 100% renewable energy systems can function reliably in and the pathways produced with these models are feasible and can function reliably. Well, now we see that feasibility of a renewable energy system is not questionable, particularly if seen and analyzed through the lens of detailed energy system models. But let's see how this is translated in the area of markets. And here we see what is going on today, a rapid increase of investments in clean energy technologies. But maybe this absolute rise, absolute increase is not that much important. If we put this relative to rise of the energy demand, we will see a dramatic outcome. So when clean energy grows faster than demand, fossil fuels lose their space. And I love this beautiful graph from Liebreich, the pragmatic climate reset, which shows that if we manage to ensure that a clean energy grows faster only with 2-3% in the next 10 to 15 years compared to demand, then in the year 2060 or somewhere around, we will have fossil fuels squeezed. And it's simple arithmetics. No policies, no international agreements, no targets. Market itself. Market as an agent who is pushing and phasing out the fossil fuels. And this is reality, and luckily for the green transition is irreversible. So, what we can conclude? Overshoot is not a failure, as some of the people would have tried to explain or interpret or use it as an excuse for action. But it is a timing problem. And we see a great success of markets in a resistant system. Why? We have delayed, accelerated but delayed deployment of renewables. We have hesitant policies, but also many lock-in of fossil fuel infrastructure. So overshoot happened in a resistant system, but still the prospects are good, and there is still room for us to be confident that, particularly with the previous graph, that we will manage to go with the overall goal of carbon neutrality by 2050. Okay. We talk about targets, we talk about tools, we talk about feasibility, but maybe it's also right time to touch upon what is going on the real ground. And that is how at national level, we feel that it's not only about CO2 reduction. Mitigation is not only about CO2 reduction, but also many other benefits for the societies. And now I will going to present some evidence from from work of my team for the national context of Macedonia. First of all, we wanted to analyze the link between climate change mitigation and national development, sustainable development agenda. And it was done through a newly developed methodology, we call it KUSCAN, which quantifies the synergies and trade-offs between a range of mitigation actions which are included in the national determined contribution and sustainable development goals. And moreover, it was not only academic exercise done by the experts, but also this KUSCAN is a simple methodology which enables involvement, engagement of the stakeholders, meaning that through this exercise we also gain on the ownership and also willingness of the stakeholders to do their part of the job in the climate action. And moreover, this exercise was in a way motivated by similar one done for the 1.5 degree special report. So it was, this exercise was included as a part of the Macedonian NDC. And very briefly about the results of implementation of this methodology. We have many synergies. They clearly dominate over trade-offs across mitigation actions, with the strongest synergy connected to clean energy, jobs and economic growth, climate action, but also land-related sustainable development goals. Also, trade-offs are there, but their magnitude is significantly lower than the synergies with sustainable development goals. And this really helped to, in a way, to counterpart the narrative that mitigation or climate action might slow down the development. And moreover, it served our national policy to make better informed decisions about prioritizing some mitigation actions which would have a broader impact on all of or on many other aspects in the society. And the other tangible results are definitely health co-benefits related to mitigation. And particularly, we calculated the reduced air pollution, which resulted, of course, in a fewer premature deaths, reduced disease burden, and also signals a very considerable cost savings. So mitigation actions and climate policies through this exercise could have been connected and in an integrated holistic planning of the development in the country. And it's not only about the health, another type of benefit definitely related to employment. And in Macedonian case, 8,000 new jobs by 2030 and about 10,000 new jobs by 2035 will be produced if all the mitigation measures foreseen in the national development determined contributions are implemented. And of course, energy efficiency dominates job creation, particularly buildings and clean heat are key drivers to towards job creation. And all those jobs are there at the spot. Look, people can see, can use the benefit of it. And again, this exercise used as can be used as and is using as a strong argument for, in a way, marketing the mitigation action. Well, we talked about targets, overshooting, models, feasibility, and also we see that renewable energy, feasible markets are already doing their job, and there is no reason not to believe that they will continue to do so in the future, and even more with more with a accelerated pace, I would say. But also we found tangible co-benefits results from the ground. So it seems that climate action is not technical. We have technologies, we have everything. But maybe it's a political or ethical issue. And so let us a little bit deliberate on what does responsible climate action mean in a world of overshoot. Well, COP30, it showed that climate cooperation is alive, as 194 countries reaffirm Paris Agreement. And also, even in the speech of the General Secretary in the end, but with all these examples, we see that transition is irreversible. We started, maybe we are not moving fast enough, but we cannot go back. And also in COP30, a lot of efforts and a lot of thoughts were put on just transition, adaptation funds, and so on. So a lot of new, in a way, additions towards international climate action was teamed out, which again we can safely conclude that this transition towards carbon neutral future is irreversible. And again, we have, out of mitigation, we have a lot of concerns, everyday concerns of the people, and mitigation take care of them through providing clean air, also affordable energy, jobs and livelihood, but also safety and resilience. Well, having said that, again, overshoot as being anticipated, and every part of 0.1 degrees still matters dramatically. What we can see that abandoning ambition is the real risk, not overshooting. So overshoot is just here, and maybe for good, because it will remind us for the urgency. But the direction is still the same, towards green societies. So we can conclude that 1.5 degrees remains an ethical compass in a world of overshoot. So, direction, but not comfort. Paris Agreement never promised that it would be easy. Integrity over pressure. So we are under pressure, but we have to deliver actions based on the evidence-based realism. And let me now make additional parallel with my lecture of climate change mitigation, will we make it in 2015? So at that time, it was the question. This conference, Sdewes conference in 2015, was just held in September, and the Paris Agreement was concluded in December. So at that time, we already had some nationally determined contributions, and I think Mexico and some other countries were among the first. But based on these pledges and many, even with the successful conclusion of Paris Agreement, at that time, the success was uncertain. And what the hope for success was driven by the success of Paris Agreement, managing, bringing on board everybody with binding for all collective action. So that was what at that time gave us a hope. So at that time, the proper question was, will we make it? But now, when we have a temporary overshoot, which is increasingly likely, but we have also clear direction, and we are witnessing an action which is underway. By wording, the question is almost the same, but we can add only small still in it, and the question now will read, will we still making? Recognizing all these factors which I mentioned: temporary overshoot happening, direction clear, and action is underway. And so now we have translated hope into action, which is very important. And well, with partial success, I would say, from the last talk taking, I think that this hope, and if we understand that we have a clear direction and we accelerate, I think this hope can be even higher than the year 2015. So we move from ambition to action. This is 2015 versus 2026. So it's not about talking and debating about goals anymore, agreeing on goals. We know what needs to be done and what we will do. So the challenge is not agreeing on goals, but turning them into coherent, fast, and credible action. And the role of science here is indispensable. It has to stress and test stress solutions. It has to evaluate trade-offs and offer some information to inform policies neutrally and rigorously. Thank you for your attention.
Thank you, Natasha. Questions? Andrea was.
Hello? Okay. Congratulations, was very interesting, your presentation. And I'd like to start and say that I agree with you. Climate change is an ethical issue, and we have to discuss about social justice. And just to point that half of CO2 emissions globally is coming from 32 fossil fuel companies. This was published today in The Guardian. And what do you think the Brazil strategy, the COP presidents of COP 30 presidents, is working outside the UN framework and is pushing the agenda to translate the target into actions, like with the Belém roadmap and other initiatives, because it's going more difficult to have a consensus. We cannot have, especially in the situation, geopolitical situation. Do you think that this could be another strategy working parallel to accelerate this transition and translate the hope and ambitions in actions? Thank you.
Well, I think that it's a global problem. So I think we need still a global approach and global target, which is 1.5 degree. But how it will be implemented in various contexts strongly depends from the context. And I think that yes, all of the countries, through their nationally determined contributions, they can provide very country-specific measures, and even not only mitigation, including adaptation as well, particularly in vulnerable countries. And yes, direct answer to your question, we still have to stay under this umbrella 1.5 as a ethical compass, but everybody should honestly put their own efforts. And then again, as I showed for the markets, probably you mentioned fossil fuels companies. Yes, but with the time being, market will work for clean energy, and market learn from costs, drop of costs, from learning curves, and also economy in scale. And these factors will, whatever resistance would be on a fossil fuel side, these factors at the end will win, because its economy is on the side of clean technologies. Not now, not today, maybe in 10, but it was shown, arithmetics shows in around 2060. But till then, all of the countries should devise most appropriate, integrated response to the need of climate action, which will address mitigation and adaptation and damages simultaneously. And but everything should stay under umbrella of this Paris Agreement.
Okay, let's pass now
Thank
to
you.
Nevin.
Okay, I fully agree with you that markets will now take over from politics, and it's already happening. But there is one issue that is kind of behind, hiding here, is that CO2 going into atmosphere stays for around 500 years. So once we did overshoot, the only way to get back down is to have carbon dioxide removal technologies. So could you comment on that side? Because that side is more complicated than energy transition, but it will be necessary.
Yes, I can comment. We go with many questions to answer. Definitely in the mix of the mitigation technologies, just because of the reasons you mentioned, we still have to withdraw some. These technologies will be, but maybe they will come later. And we have to try to go with scenarios which will, based on clean technologies, and which will now at least produces less or zero emissions. And for that, what is there still in the atmosphere? Yes, at some points we will need to have this kind of carbon capture and storage technologies. But for the moment, I think the focus should be on clean renewable energy sources. But definitely they will be there, but not in amount which is currently foreseen of by the integrated assessment models, because this large amount of this carbon removal in the pathways is just a result of the limitation of the models, and it's not in the real interpretation of the feasibilities of other options. As they are designed now, some kind of carbon removal options are favorable over the renewable energy sources. But we need to change, to improve our models in order to be able to capture these new other technologies which are in a way more beneficial.
Okay, please.
Thank you. I have
Please
to
identify yourself.
yeah, exactly. I'm Daniel. I'm coming from Canada, one of the worst country in the world with respect not to overshoot of 1.5, but with the ecological footprint. We have our overshoot day on March the 9th every year or something like that. So this to set the point. My actual action is with teenagers from 12 to 16, and your presentation is pretty enlightening for them, because what I realized with a couple of colleagues a few years ago is that the most brilliant of them, I mean, they go for inaction. I mean, they refuse to see it and say, we're fucked up anyway, so we won't do anything. And I'm presenting them with teams of grad students that are going into schools. They explain what climate change is and what they should do, and this will enhance. So thank you for the enlightening presentation. Second, in my country too, we have a large part which is permanently frozen, and it holds a bunch of methane there. And every year, tarmacs, houses are falling because everything is melting. And my question is, don't you think that inertia will eventually catch up on us? I mean, you say if we stop emitting, like our colleague said, still there will be some increase in temperature anyway, and the phenomenon that I just discussed, are your models accounting for all of that? Whether tomorrow we stop everything and then we wait, what will happen? I think temperature will, I'm not a specialist in climate, but I think temperature will still be rising for a couple of decades, if not a century. No?
Yeah, that's why I said that now some of the models produce results which in a way suggest that yes, we have time and we could wait, because immediate action is not cheaper, much more expensive.
Yes.
And we also have some scenarios, for example, being based on nuclear, which so for till nuclear comes, we can still go on fossil fuels and freely emit CO2 in the atmosphere. But what you mentioned here, the models, these integrated assessment models now, they take this also new, not only burning fossil fuels, but other sources. And then that is why we need to improve, I mentioned, improve the models in order to be capable to, in a way, to produce better information for the policy, and to make this visible that it's maybe even it's too late for the action.
Okay, because when I saw temporary overshoot, I think temporary could be for,
Yeah,
we could be above 1.5 for a long time.
Yes,
that
we
was my
have
question.
to devise trajectories with a minimum to short this overshoot,
Yes.
and also to minimize this peak of the emissions.
Yes. Yeah, of course.
But
I
that
agree
is
with
also
goals and all. Yeah.
depends on the action.
We have another question.
My name is Paul Østergaard from Aalborg University in Denmark. I might be stepping along the same path that Daniel from Canada was treading, because when I saw your presentation, I felt it was nice and being confirmed that it actually still matters that we can overshoot and then we can get back on track. But then I'm also starting asking myself questions. Well, what about the footnotes? So you mentioned methane release from the Arctic. You have the same issue in Russia, of course, but you also have issues like ocean currents. You have the albedo effect in the North Atlantic. I mean, ice is melting and the oceans are getting warmer and warmer. So I'm just wondering, can we, without very extensive carbon capture, as Nevin was also suggesting, can we still have an overshoot and come back on a reasonable track?
I think now IPCC is starting 7 assessment report, and all these new developments will be, I think, very well represented in the modeling work. And and I think that with newly and improved models, we could find still well representing these new developments in the models and also devising appropriate solutions. Maybe, yes, we can, or the need for carbon removal will increase. We have to see new pathways taking into account all new developments. But I do hope that something will come out of the new 7th assessment cycle of IPCC.
Thank you for your presentation. My name is Sai and I'm from the Cayman Islands. Looking at that graph, worried because Cayman Islands is a very low-lying island. It's like 5 feet above sea level, the Grand Cayman Island. So during that intervening period, we may be well underwater. That gets me worried. And I think we should be looking at adaptation, at least in Cayman. Because it's a small island, there's only so much we can mitigate. So, yeah, that's just a comment.
Yeah. No, adaptation goes without saying, but let's do a lot of mitigation. Where do you cut emissions? It's not important. Maybe you cannot cut emissions at Cayman, but everywhere can be cut it, and how much is cut, this is what matters. So a strong mitigation action, which will not allow to some areas to be with that to be flooded, it's what we need to do, and for that we need a very strong mitigation action.
Gains and more intense,
yes,
because of all these changes. So, and some parts of Florida are uninsurable. Not many people are willing to insure property because of increase of hurricanes and flooding.
Still, with 1.5 degree ambition, I think that the costs for adaptation and damages which occur as a result of climate change can be lower than mitigation itself, higher than mitigation itself. So it's cheaper to invest the humanity as a whole, to invest in mitigation, not to allow all these things to happen.
Isaac Diner, Colombia. I'm a bit worried that the message may fail in some points. Mm-hmm. And to leave it to markets, I think is very dangerous. And the political scene these days is not in favor of what we want the world to move into for controlling a bit of overshooting. The temptation for many governments, we're not going to meet the goals, so let's postpone this. And that's what you say is correct. It's not a good medicine, but it may be the medicine for deniers. And so the battleground, I think, it would be to create a more critical mass in favor of your message. And let's not give up in terms of, regardless of not meeting the goals, we should, because the technology is there or is in progress, and it's not like in 2015. So we are better prepared for fighting this. But it's the opinion that would count and changing the political mood that we see today.
Okay, I fully agree with you. I never mentioned that we should leave everything to markets. In strong when I'm saying mitigation action, strong mitigation action, I don't think only technology. The mitigation actions has a many dimensions. Technology is one of them, but we have also policy, we have also communication, we have stakeholder engagement, and many other dimensions. And yes, market is doing very good, but let's use it as a showcase to the other dimensions to be stronger, like to devise better policies, to even to support further the markets to do the job. This is the my take. So I'm not saying leave it everything to markets and they will do the job. This is arithmetic just to show where the things are going. But still we need acceleration, and that acceleration should be with proper policy, with proper institutions, with proper people, which will be aware, which will have a right understanding what overshoot, for example, is and what it is not, and then clear action should be on the ground.
It's interesting how my carbon dioxide removal was translated by all later questioners to carbon capture and storage. I never mentioned carbon capture and storage. I mentioned carbon dioxide removal because the way I see it, we are going to have energy which will be too cheap to matter. Solar panels are becoming so cheap that we will be able to move towards vertical agriculture, to lab meat production, and to return back most of agricultural land to forests. And reforestation is the cheapest carbon dioxide removal technology, which has actually negative cost because you can use this forest for further harvesting of wood for furniture, so you earn money on that. And as Brer has shown, we have technology, and soon it will be viable to reforest Sahara in Egypt, for example, using desalinated water, all coming from solar panels. So this is the way how to reduce that bulge that we are going to create now. It's not going to happen tomorrow, but in next 20 or 30 years, I see this starting to happen. The technologies are here.
I guess there's one more question, and that's it.
I presume everyone wants to go for lunch. I try to keep it short. Thanks for the words of optimism. Until a year ago, or a few weeks ago, I would have agreed with you in like 80% of the things. But now with the new geopolitical situation, I mean, it's highly speculative what you could say anyway. But I would like to hear your take, because the reality that we had 1.5 years ago to the one that we have today with this crazy guy up in the US just doesn't match, right? 1.5 years ago, we were a world trying to have a transition, trying to fight for this 1.5. Now it's like a very divided world with a lot of things around. So if you kind of spend some thoughts.
My take on this is, I also consider Trump as an overshoot, and the wish would be the peak to be lower and the duration also lower. That would be the answer to your question.
Okay. I would just add one thing. you're using process control dynamics response. Yes,
yes.
it's one of my areas.
Yes.
And there is this remaining curve is the offset.
Yes.
So it might not be exactly like Nevin say, how much offset can we stand? And would, I guess, adaptation be the solution for offset?
Yeah, adaptation and maybe some solutions for carbon removal.
Which is very expensive. So who will pay for this? CDR is the most expensive. So the market, by
and
market,
forests maybe.
Yeah.
Forests.
Nature-based solutions. Okay. Thank you very much, and I would like
Thank you also
to
for all the
applause her and,
contributions. Okay. Thank you very much.